Hi everyone, this is a quick review video to get ready for our fourth quiz of the semester. Quiz 4 is a take-home assignment, so you'll have all day today or Tuesday to complete that quiz. And this is also going to be our first bit of review for Exam 2. Exam 2 will be 1 week from today, meaning October 9th or next Tuesday. So all of the review questions that I'll go over in this brief video will come out of that first practice exam for Exam 2, which is posted on Canvas, and these problems will also relate strongly to what's going to be on your fourth quiz. So in that way, you'll be reviewing a little bit for each of those. It'll just be 3 quick problems. So the first of those problems is number 17, which again is drawn out of that first practice exam. And number 17 says that we estimate 74% of people prefer Coke to Pepsi, and out of a sample of 50 individuals, we're interested in the probability that more than 78% of the people sampled prefer Coke versus Pepsi. One of the big things to see in this problem is that we're concerned with what happens with the probability pertaining to a sample as opposed to an individual value. So we've talked a lot the last couple weeks about putting probabilities on the normal distribution, and generally if you're dealing with a single value, then you would not start with a standard error. But here we're dealing with a sample of 50 individuals, and if you ever see wording like that where you're interested in the probability that a certain thing will happen to a sample, generally the way you want to start is with a standard error. And this one is dealing with specifically a proportion. So we're not dealing with, say, 6 people or 8 people, but we're dealing with a certain percentage of people. So 74% of people on average we think prefer Coke to Pepsi. That proportion, or that fraction out of a whole, means that we're going to deal with a different standard error formula versus if we were dealing with a mean. So since we're dealing with a proportion, our standard error formula, which is on the formula sheets that were handed out last class, is as follows. So standard error is the square root of p multiplied by 1 minus p and divided by n, where p is that proportion of success and n is your sample size. So in this example, we think that 74% of people prefer Coke to Pepsi. So 0.74 for that 74% is going to be our p. So 0.74 in the numerator, and we multiply that by 1 minus 0.74, which would just be 0.26. And finally, in the denominator, we're going to be dividing that by our sample size. So we're interested in a sample of 50 individuals, so divide by 50 for our n. And that quick formula is going to give us our standard error, which will essentially put this problem onto a normal distribution. So if we work out the math on this one, I believe what the standard error should come to is about 0.062. That standard error step is, I think, the most difficult step of the problem, because once we have that standard error, this problem becomes a normal CDF, which is very, very similar to all the other problems we've done with normal CDF throughout the last couple weeks. And all of our normal CDF problems, we generally will start by specifying the same 4 parameters. So those 4 parameters are going to be our lower bound, our upper bound, our mean, and our standard deviation. And at this point, between the problem and the standard error that we just calculated, all of these should be known to us. So the problem tells us we're interested in the probability that more than 78% of the people sampled prefer Coke to Pepsi. So if we're interested in more than 78%, that lower bound is just going to be 0.78. Sorry, it keeps switching slides on me. Upper bound is not defined for us in the problem. So we're just interested in more than 78% of people. That means for an upper bound, we just need to put a very, very large number. So the number I like to put is a lot of 9s, 99999, so that we get the rest of the area under that distribution between 0.78 and the far, far right bound of the distribution. The mean or average value is the next parameter that we have to put in. So on average, we think that 74% of people, or 0.74, prefer Coke to Pepsi. And the last thing to do is to put in our standard deviation. And in this case, our standard deviation is going to be the same as our standard error. And we actually just calculated that one to be 0.062. And that's what that standard error step does for us, is once we're on that normal distribution, we need to know how much variability there is or what our standard deviation is. And the standard error tells us the standard deviation of that sampling distribution. Now that we know all of this, the last step is to plug it into normal CDF, and that'll figure out the probability for us on that normal distribution. So the 4 parameters always go in the order that I've written them here. So 0.78 as our lower bound, 999,999 as our upper bound, 0.74 as our mean, and our standard error, which was 0.062, goes in where we would normally put our standard deviation. Last thing to do is plug that all into the calculator and hit enter. So if you do work that out on a calculator, lower bound 0.78, upper bound 99999, mean of 0.74, standard error of 0.062, I believe the value that should come out to is about 0.2595. So about a 26% chance that more than 78% of the people that you sample would prefer Coke versus Pepsi. So the big steps with this problem is first identifying what type of problem it is. It is a proportion question because we've got this fraction out of a whole 74% of people on average prefer Coke to Pepsi, and we're interested in a sample where more than 78% of people feel that way. And it's a sample, meaning that we start with a standard error. And that standard error formula for proportions is always going to be square root of p times 1 minus p divided by n. We work that out here to get 0.062, and then that's the hard part of the problem because the rest of it is just plugging it into our normal CDF to calculate on the normal distribution what our probability would be. So we put in our lower bound, upper bound, mean, and our standard deviation or standard error here, and get our probability on that normal distribution of about a 26% chance. Next problem that we'll look at, we are dealing with some BIT students' exam scores. So in this case, exam scores followed a normal distribution with a mean of 75.2 and a standard deviation of 6.1. We're sampling 50 student scores, and we're interested in calculating a 90% confidence interval for the mean. One of the quick things to identify with a problem that's asking for a confidence interval is what type of confidence interval it's going to be. And the two types of confidence intervals that we talked about are basically the difference between what type of distribution are you going to use. So are we going to use a z distribution or are we going to use a t distribution? And the test that we looked at for that was taking a look at our sample size. So in this case, we've got a sample size of 50 students. And from class, we talked about the dividing line being 30. So if n was greater than or equal to 30, we used a z distribution, also known as the normal distribution. And if n was less than 30, we would have to use the t distribution instead of the normal or z distribution. So in this case, because we've got a sufficient sample size, meaning 50 students, we are okay to use the z distribution. Next step that we need to take, once we've identified that it's the z distribution, is we actually need to figure out our critical value. And our critical value is going to come from the critical value table that was handed out in class, which pertains to the z distribution and to the t distribution. So I'm going to get out of the slides for a moment just so that I can go to that table. If you were in class last time, you should have a handout that looks a bit like this PDF. So on one side of the PDF, you'll have t distribution critical values, and on the other side of the PDF, you'll have z distribution critical values. We said that this one was z distribution, so that's the part of the table that we're going to go to. If you are missing this table, or if you need another copy of it, if you look up on Canvas under the Files and Statistical Tables, you'll see a document called Critical Value Tables for Exam2.pdf, and that's the one that you'll want to look for, and that's basically the same PDF that was handed out in class. And if you do need them, another copy, I will have extras next class and hand them out at that point as well. So for this problem, we are interested in a 90% confidence interval for the mean. So what we do is we go on our z distribution critical values table and look for that 90% or 0.9 confidence value. And from the table, our 90% will correspond to a critical value of 1.645. So once we've identified it's a z distribution, we basically just have to read it off of the table, and we get that 1.645 for our critical value. So it is just that simple, reading it off of a table. If we had n less than 30, we would have gone to our t distribution instead, where we would have had to cross-reference our sample size with our confidence level. But the z distribution one is actually a little bit easier. The sample size is irrelevant. We just look at our confidence level, so 90% corresponds to 1.645. So heading back to the slides, we've identified our critical value now. Our critical value was 1.645, reading off of that table. Next thing to do for any confidence interval that we go through is to calculate out our standard error. And from this point, once we've got the critical value, basically all of the confidence intervals that we've discussed work the same way. So we do our critical value, we do our standard error, and then we put them together for our margin of error. So standard error formula, this time we've got a standard error for a mean as opposed to a standard error for a proportion. So the standard error for a mean, the mean exam score for these BIT students, is just the standard deviation, SD, over the square root of n, our sample size. So we're told that we have a standard deviation of 6.1 on the exam, and we have a sample size of 50 students. So 6.1 over the square root of 50 to figure out what our standard error is going to be on this problem. And I believe that our standard error, if you work it out, should come out to be something like 0.863. Once we've got our critical value and our standard error, we can start calculating our margin of error. And our margin of error tells us how wide does our confidence interval need to be. How much wiggle room are we going to put on either side of the mean so we can figure out where our upper bound goes and where our lower bound goes. And that's why figuring out the critical value and the standard error were so important, because our formula for our margin of error, which I'm abbreviating here MOE, is just our critical value multiplied by our standard error. So we figured out our critical value from that critical values table. We calculated out our standard error. So now we know both of those components. Our critical value was 1.645 from above, and our standard error was 0.863, also from above. And we just multiply those together to figure out our wiggle room, or essentially how wide a confidence interval are we going to make. And if we work out the math on this one, I think we get a margin of error, a value approximately equal to 1.42. And again, what that margin of error value is telling you is how wide do you need to make your confidence interval? How much distance do you need to put between your mean and your upper bound, and between your mean and your lower bound? And that's really the last thing to do, is figure out that upper bound and the lower bound. So our final step is our mean plus or minus our margin of error, and that'll give us both our upper bound and our lower bound. Referring back up to the problem, we had a mean of 75.2, so I'm going to plug in 75.2 as the mean. And we're going to do our mean minus our margin of error for our lower bound, so margin of error 1.42, and our mean plus our margin of error 1.42 would give us our upper bound. So in this case, on this problem, I believe that the lower bound, which is 75.2 minus 1.42, would come to a value of about 73.78. And our upper bound, where we're adding that margin of error onto our mean, comes out to a value of about 76.62. And these two values form your lower bound and your upper bound respectively, and then you have enough information to finish the problem. These are your final answers. You know your lower bound and your upper bound, and this is what you submit for credit on your quiz. So a lot of steps in this problem. We started with figuring out our critical value, which was coming off of that critical value table. We identified that it was a z-distribution critical value because of our sample size. So n was greater than or equal to 30, and that's why we went to that z-distribution table. If n were less than 30, we would have had to go to that t-distribution table instead. For our standard error, we did our standard error formula of our standard deviation divided by our square root of our sample size to figure out our standard error. We multiplied critical value by standard error to get our margin of error, or amount of wiggle room either side of our mean. And then finally, mean plus or minus the margin of error gave us our lower bound and our upper bound, 73.78 to 76.62. Now there is a calculator way to solve this problem, so I'll remind you of that real quickly so that you can also use that on the quiz if you so choose. So here is my virtual calculator, TI-84. And the calculator functions for this are actually very conveniently located. They are under the stat key. So at the very top of the calculator, it's the second row, and then over sort of towards the right of the row, there's a button that says Stat. Click on that Stat button, and you'll get to this menu, which we've actually seen a couple times before in the class. What you want for this particular one is to arrow all the way over to the right for where it says Tests. And underneath Tests are all of the confidence interval functions on the calculator. You have to scroll quite a ways down to get to this one. The two intervals that we would use for the mean are going to be called Z interval and T interval. So number 7, Z interval, is what you use if you have a Z distribution to calculate a confidence interval for. Number 8 you would use if you have a T distribution to calculate a confidence interval for. So this one, if n is greater than or equal to 30, we're on a Z distribution, so we select that option. Here I've actually already entered in all of my parameters, but I'll go over here what each of them is. Up at the top, you always want to select stats as opposed to data. If you select data, then instead of asking you for these parameters, it'll try to read the data out of a list, which isn't what we want here. Then you're asked for sigma, which is the notation for your standard deviation. So a problem gives us that as 6.1. X bar is our mean, which the problem gives us as 75.2. N is our sample size, which the problem gives to us as 50. And finally, C level, that's our confidence level. What level confidence interval do we want? In this case, we want a 90% confidence interval, so we enter in a 0.9 here. It's very, very important that that C level or confidence level be entered on a 0 to 1 scale. So 90% confidence interval is 0.9, 95% is 0.95, etc. If you just enter in a whole number, it might give you an error message. So always enter that as a 0 to 1 scale. Here, 0.9 means 90% confidence interval. Hit calculate at the bottom, and the calculator will do an incredible amount of work for you. And up there at the top, it gives you the lower bound and the upper bound. So lower bound 73.781, upper bound 76.619, matching very, very closely to what we got working it out by hand. So you should get the same answer pretty much either way, just maybe a small rounding difference. And this can save you a lot of time on the quiz or on the exam. One caveat, which I also mentioned in class, is that this function does not show any of its work. So I could ask you on the quiz, or I could ask you on the exam, what's the critical value for this problem, and not make you go all the way through to figure out the lower bound and the upper bound. Or I could ask you, what's the margin of error for this problem, and not ask you to go all the way through. So I believe on the quiz I did ask you to go all the way through and give the lower bound and the upper bound as the answer. So on the quiz, this calculator function is totally fine and it gives the correct answer. But on the exam, there will be some problems that just ask you for, say, the margin of error. And in that case, you do need to know how to calculate that value. Heading back to the slides, we've got one more problem to do to get ready for the quiz, and then that'll be the last one for this review video. So this last problem is giving us a minimum sample size question. So we want to do a confidence interval for the mean, but we don't have a data set yet. So we're interested in how big a data set, how many values we need to sample in order to properly estimate our confidence interval for the mean. So we think that the population variance will be about 400, and we want to calculate a 99% confidence interval. And in that case, what is the minimum sample size that we need to estimate the mean with a margin of error of 0.5. So first thing we're going to do is actually write out the formula for our problem so we can see what components we need. So our formula is that n, or our minimum sample size, is going to be equal to our critical value times our standard deviation all over our margin of error squared. So looking at the components for this problem, the critical value, the standard deviation, and the margin of error are the three things that we're going to need. Critical value is going to come out of that Z distribution critical values table. So I'll head back to that PDF one more time. For any time you're calculating a minimum sample size, you are always going to go to that Z distribution table. So don't go to T distribution because you're not going to know what sample size to plug in. Always go to that Z distribution table. And here we were interested in a 99% confidence interval, so it's the very last row of the table. We want 2.575 as our critical value for this problem. So 2.575 is what we want for a 95% confidence interval. Heading back over to the slides, we know that our CV, or critical value, 2.575. Next thing we need to know from that formula is we need to know our standard deviation. And actually, one tricky thing about this problem is that it doesn't give that to you. It's a little bit tricky. So it gives you a variance instead of giving you a standard deviation. If you remember from our first exam, the standard deviation is actually defined as the square root of the variance. So if the variance is given to us as 400, the standard deviation is simply the square root of that. So it would be the square root of 400. And I made the math fairly friendly on this one. So square root of 400 will just come out to be 20. At this point, we are ready to start plugging things into the formula. So n on this problem is the critical value of 2.575 multiplied by our standard deviation of 20 divided by our margin of error, and then all squared. And if we take a look at the problem, it tells us we're interested in calculating an estimate of the mean within a margin of error of 0.5. So in our denominator, for our margin of error, 0.5 is the value that we're going to plug in there. And if we work out all the math on this one, try to figure out what our minimum sample size is going to be. It's actually quite a large sample size. We need, I think, 10,609 as our sample in order to estimate this confidence interval. And that is going to be the final answer to this question. One last thing to note here on these problems where you're calculating the minimum sample size is that if you get a decimal as your final value, you're always going to round it up to the next integer. So in this particular case, you actually just get a whole number as your final answer, which is 10,609. And in that case, just give 10,609 as your answer, and that's great. But if you were to get a decimal, you would always round that decimal up to the next integer. So say I got 10,608.1 as my answer, I would round that up to the next value of 10,609. Always, if you get a decimal, you would round it up to the next value, even if it's a very, very small decimal. Here we got a whole number, so we didn't have to do that, but if you did get a decimal, please remember to round that decimal up to the next value. So that concludes what I wanted to go over for the review video. I think that the quiz should follow pretty closely from this. So if you know how to do your confidence intervals, you know how to do your minimum sample size, and you know how to do that central limit theorem problem where you're figuring out the probability of a proportion within a certain range, you should be in pretty good shape for the quiz. So best of luck on the quiz and in getting prepared for the exam. We'll talk more about that exam on Thursday and get prepared then. So until then, best of luck on the quiz, and see you soon.